Okay, it's time. Good morning, everyone. I'm Chieri Kubota. I'm a professor at the Ohio State University. Welcome to Indoor Ag Science Café. Thank you for attending today, which is usually 11 a.m. Eastern, but we decided to do that 10 a.m. so that it is a little bit more friendly to our speaker. So this effort is an extension effort funded by USDA SCRI. The team member is Michigan State University, Ohio State University, Purdue University of Arizona, basically providing science-based information to the stakeholders, industry members, academic members who are trying to be successful to conduct indoor crop production. So let's get started today's content. So as usual, I like to give a heads up about the upcoming schedule of Indoor Ag Science Cafe talks. So today we have a special speaker from Japan, my colleague and then also good friend, Shimamura-san is going to be here. And April is a scientist from Wageningen University talking about speed breeding and phytate influence speed breeding or improve the speed breeding efficiency. So that's interesting topic. May we have 3M R&D person, and it's a greenhouse topic because we are trying to expand the scope, not just indoor vertical farm, but also indoor general greenhouse CEA, controlled environment agriculture. So the topic is managing sunlight light quality by using thin films. June, we have another company speaker, Denso, who is going to talk about their approach to Toyota methodologies to smart agriculture, to contribute to smart agriculture in CEA. So that's line up. And then we don't have a cafe usually July, and then from August we have another series start. So look forward to that. Again, thank you so much attending today's cafe. So all right. So just a little bit of advertisement. OptimIA University is now complete, and you can learn basic knowledge of indoor farming. And so this is the website, optimiauniversity.org. I really encourage if you are new in this space, because it has a crop production information, physiology information, engineering technology related information. So it's a complete set. And then also economics and marketing. So very important set. So I really encourage you to log in or access and then learn the basic contents. All right. So today's special guest is Dr. Shigeharu Shimamura from Hanmo. And then he's going to talk about very important thing in indoor vertical farm, which is air contamination or air contaminants in indoor vertical farms. And then he's going to show case study on VOC effects on crop productivity in 2 commercial farms. Because of the language issue, I would like to have Shimamura-san to introduce himself, but after that, I kind of take over and then introduce his contents in my way so that you can probably better understand, but the contents are originally Shimamura-san's. So while I'm switching my presentation, Shimamura-san can introduce yourself.
Okay. My name is Shigeharu Shimamura. So I am the CEO of Hanmo Corporation. I'm very happy to share my experience with you all. And thank you very much, Dr. Kubota. The presentation will be given by Dr. Kubota. Thank you.
Okay. All right. ありがとうございます、島村さん。
Hi.
So, as usual, this part is going to be recorded. And then after that, we have an unrecorded Q&A. So please save your questions. You can start typing your questions in chat area. or save your questions. I usually, encourage you to use microphone too. But anyway, so again, the title is Air Contaminants in Indoor Vertical Farms, a case study on VOC effect on crop production in 2 commercial farms. Okay, all right. So just a quick introduction again about the speaker and then also his company. So the Dr. Shimamura was born in Tokyo, and then he is specialized in many different things: vegetable crop production, plant factory, hydroponics, vertical farms, artificial intelligence. Excellent set of expertise. And then he is the president and CEO of Hanmo. And also he serves as lecturer at Chiba University in Japan. And here is his email address. If you want to directly communicate with him, you can do so. The company, Hanmo, is relatively new, founded in 2016. However, Shimamura-san has worked in this space probably nearly 20 years, maybe longer, maybe he can clarify later, but he has a long-term contribution as a business person in this space. And then the location of Hanmo is now in Chiba University, Kashiwanoha Innovation Campus. And then they are doing business, including business planning and consultation regarding crop production, research and design, and sales of crop production systems, and research, design, and sales of agricultural machineries, obviously to apply in indoor vertical farms. Production and sales of actual products, fresh vegetables and fruits grown in vertical farms. So those are the business areas Hanmo has been conducting. And the vision of Hanmo is pretty much systems approach, and then they consider they can design produce quality and flavor and productivity using this 3-way approach: the plant side, genotypes; environment side, environment microclimate; and then also human factors. So Hanmo is uniquely situated in the center so that they have access to all 3 aspects, very important in indoor, successful indoor agriculture. And then something to note here, Hanmo has foundational knowledge base for indoor production of leafy greens and culinary herbs, covering more than 50 different crops, including species and cultivars. So that's something amazing. I don't think many companies have this experience. And then they have been working domestic market, so that in Japan, and then also international market. So this is one example client. Picture shows the production system, the typical multi-tier stacking system, vertical farms with LED lights, and leafy greens are grown nicely in that system. Another one I like to show here is strawberry production in a vertical farm setting. This one is actually based on old building, so the renovated school building. So they are doing strawberry production here for U-pick operation. So the tourists come and then do U-pick year-round without seasonal issue. So this is the view of the production room, and then this is a close-up of their strawberry crop. And in terms of international or overseas projects, this is one example from 2019. They have Hanmo built campus indoor farming at Mahidol University, Thailand, or Mahidol University, Thailand. And then Hanmo was collaborating with the university and then also Chiba University. So this is the project members in front of that facility. Another one, this is a commercial scale, also in Thailand. This is actually a production capacity of 1 metric ton per day. So every day, 1 metric ton per day. So the 1,000 kilograms of lettuce produced per day. Beautiful facility, clean environment. So that is another successful overseas project of Hanmo. So today's topics is VOC. VOC is volatile organic compounds. And this is actually my slide. I thought it is good to start with this so that those who are not familiar with the topic can be familiar before listening to what Shimamura-san originally prepared. So we know that plants and many industrial materials used in plant growing systems emit a wide range of volatile organic compounds. And then most VOCs are not problematic, so you don't need to worry about. But some VOCs are phytotoxic at very, very low concentrations. So the issue was noted many researchers. I think the earliest one was greenhouse researcher, and then growth chamber-based NASA, researchers, and Ted Tibbetts in University of Wisconsin actually wrote several nice review articles telling that, the very quick symptom, such as 24, 96 hours of exposure, and then inducing the symptom. And then also, he noticed that sensitivity to VOCs is pretty much species specific. However, the challenge of this VOCs and their sources are often very difficult to identify, and then often very challenging to remove. Sorry, I have a slow problem, so I need to just give me a second. So Arabidopsis plants were exposed to different VOCs. So those were actually known VOCs, but researchers wanted to test the response of Arabidopsis plants to selected VOCs. And then as you can see, some of them completely kill plants, yellowing and kill, but some of them are just slightly reduced compared to control group, slightly reducing the overall growth. This is very rare type of research. We couldn't identify any other good differences. Again, limited research has been conducted, especially for plant response. And then we talk more about that, about this issue. And we have also in OptimIA University, we have also one lecture specific to VOC. So if you are interested in learning more, I encourage to connect OptimIA University and learn that. All right, so back to Shimamura-san's content. So Shimamura-san's content include introduction of 2 farms of a company operating leafy green production under typical vertical farm setup. And then he wanted to introduce some of the mini experiments to confirm that VOC was likely the issue. And then wanted to introduce or share the how also confirm that VOC by venting the facility. And then specific recommendation and future perspective. All right, so the beginning is actually 2 farms under one company. And then issue was noticed in one of the 2. Specific issue I'll show you in a minute, but steady reduction of productivity. So before going into the data of productivity, I like to focus here the difference between two farms. So nearly the same size, same productivity. Farm A, the construction materials farm A, it's just showing here, exterior walls were ALC, area or lightweight concrete, I think that abbreviation, ALC, concrete panels. Interior walls were metal insulation panels. So the metal sandwiching insulation material, metal insulation panels. Lighting was LEDs, and production capacity is 10,000 lettuce heads per day. Only one room, so the one big room, but 10,000 lettuce head capacity per day. Farm B, which is a problematic one, main materials were wooden structural materials. So those were used for walls. Lighting, a combination of fluorescent lamps and LEDs, and according to Shimamura-san, mostly fluorescent lamps. Production capacity, there are two rooms in that farm. One is, each one has 5,000 lettuce head per day production capacity. Two together, 10,000, therefore exactly the same or nearly the same as farm A. All right. If you look at the plants, they look green, they look okay. There's no big difference other than B looking a little bit of, reduced growth. But just by looking, it's not like a typical VOC severe issue. So the plants are green, plants are growing. However, if you look at the data closely, this is the issue. So this is the lettuce crop fresh mass per head, so the per plant, recorded over time. So x-axis, I couldn't convert to English, but I think you can figure out February 12th all the way to April 16th. So that 2 months, about 2 months of productivity. Leaf lettuce, just tracking that yield every time they harvest. So the fresh weight at the beginning, you see that 75 grams or so, and then steady decline. And then after 2 months, it's less than half of the beginning. So that's a huge issue. By the way, there are two different data types here. One is the original fresh weight. The other one is the fresh weight after trimming. Just because the data was available, it's included, but it's not so important in this VOC thing. So you can ignore that. Just the overall trend is what you want to focus. So that's farm B. And this is a comparison between farm A and farm B. So the production system generally the same. And then I mentioned that difference in the structural materials and lighting are slightly different. Farm A, the same cultivar, same type lettuce, steady productivity. It's a slight up and down, but it's not like this. It's between 75, 85 per head grams. Again, farm B is steady decline. So that's a quite serious issue. This is different cultivar. It's a cultivar of what we call frill lettuce or frill leaf lettuce. And then again, the same thing. Farm A, no issue. Some fluctuation, but no issue. There's no steady, obvious decline. Farm B, again, over the 2 months of period, yield is steadily declining over time. So again, the beginning is somewhere close to 45 grams, and then ending is less than half. So that's a huge issue. And then again, if you look at the plants, yes, plants may look a little bit smaller, but it's not really yellow or, necrosis or dying or anything like that. Maybe slightly elongated, but that's the maximum observation or the noticeable observation of this farm B. So, of course, wanted to find out what is causing this. So they did investigation about possible causes for productivity decline. And the fact is, continuously decline, right? Over time. And then they looked at system setup, environmental conditions, and then tried to analyze the cause. So one thing they thought was the difference of lighting source. The light source in Farm A is LED lights. Farm B, mainly fluorescent lamps. So they thought maybe fluorescent lamps reducing the photon flux. So that means the power emitted or light emitted by the lights. So they tested increased light level. So increased PPFD during the 2nd to 4th week of crop growth to overcome the low productivity in Farm B. They didn't increase the final stage of crop growth. Why? Because of the risk of tip-pan. You don't want to mess with the final week of or whatever the phase of lettuce growth. So they did strategically the midpoint PPFD higher. In addition, working with expert, they improved the nutrient formula, thinking that that might be another way to improve the productivity of the Farm B. However, none of them worked. Neither of them worked to improve the yield, and then continuously a problem observed in Farm B. So Shimamura-san's group basically looked at literature, communicated with different scientists, and then thought that air quality VOCs or volatile organic compounds can negatively affect plant growth and development. And including those I mentioned earlier, various compounds are reported to affect plants as well as humans. For human side, I think you may be familiar with sick building syndrome. You can't, the sensitive people cannot live in certain environment containing health, containing VOC affecting health negatively. However, because of that human side, we have a human issue. We have a lot of human related information, but not so much about plant issue. And almost all literatures dealing with VOC effects on plants usually report severe phytotoxicity, yellowing or stunted growth. And probably there are minor effects, a little bit reduced growth rate observed, but researchers probably didn't pay too much attention on that. So likely ignored. So that's why we don't have much report out there. VOC levels affecting human health are likely higher than those affecting plants. So the plants are more sensitive than human. So that's why we don't have much information about the materials emitting problematic VOCs and VOCs itself for the plant growth. So Shimamura-san's group did a further analysis and found that or confirmed that Farm B seeding, right, was actually not completely sealed. So the team thought that it may be possible that VOC generated from construction structural materials or maybe caulking materials to seal or the ceiling or the walls diffused into the production room to affect crop growth in Farm B. So based on that thought, they launched small project to identify the impacts of suspicious materials. So I like to show that results. So the small project was very simple. Shimamura-san used approach, a kind of modified approach reported by the Arabidopsis study, Lee et al. 2014. Shimamura-san introduced double petri dish systems. So large one and small one. And then large one holds the selected materials to test. And then small one holds filter paper, moist filter paper to germinate seeds. So the seeds and filter paper. And then duration is only 7 days. So put everything in, close the lid, put under the light, because lettuce usually need light. And then 7 days, and then investigate the seedling growth and color with selected materials in a larger petri dish. So this is the control. So there's no materials inside, so plants are healthy. This is a healthy control, right? So this is a frill lettuce, and then this is a green leaf lettuce, 2 cultivars. The temperature, 20 to 22 degrees C. So that's the optimum lettuce growing temperature. And light intensity was a DQA, and then the light source was fluorescent lamps. This is plywood, structural plywood used for roofing of the building. And see, those are the materials, plywood chips. And then those are the plants after 7 days, the same condition as control group. Slightly different, but it's probably hard for your eyes to identify the difference between the one before, the other way, one before, and this one. Now, this is the structural wood panels used for building walls of Farm B. You can see now elongated cotyledons, and then it's a lighter color too. Both cultivars, frill lettuce and green leaf lettuce, showing that elongation. Now, they also tested adhesive silicone sealant. So this type of materials, researchers gave a warning before, and then his experiment actually showed that very much stunted growth, and then yellow, and they are not healthy at all. So this exact sealants were used for sealing the gap of insulation panels in Farm B. So just a summary so that you can see this is a control plant. I believe this is green leaf lettuce. And then structural plywood, slightly lighter color, slight elongation, but difference was very, very small. Structural panels, 7 days in contained environment, cotyledons of frill lettuce, it's typically here, is largely elongated, and seedlings were generally etiolated. Green lettuce is same thing, narrower, and then etiolated. Silicone sealants in both frill and green lettuce, cultivar seedlings were severely stunted and yellow. So these observations showing that some of the materials emitting problematic VOC, but we don't know what VOC is. But important thing is that those results generally agree with workers' observations in Farm B, saying that slightly lighter green and elongation for young seedlings. So they did ventilation study, which is actually most effective way to confirm that's VOC accumulating in the production facility. So remember, Farm B has 2 rooms, production rooms. One kept as it is, so that keep going without ventilation. The other one vented in the middle. So starting with February, in the middle, so the March 8th, 9th, and 10th, ventilation was applied. So you can see that those 3 days, the first 2 days are just 10 hours ventilation. And then the third day was 24 hours continuous ventilation. Then as you can clearly see that, the change of the direction, so the declining up to the ventilation, and after the ventilation, the productivity was recovered. it's obvious ventilation improved the productivity of this green leaf lettuce. Different one, romaine lettuce. Again, ventilation was applied in the same 3 days in the middle, declining trend, changed to increasing trend, and then kind of stabilized. So that's really showing that VOC is the problematic issue in here. And just as a comparison, so this is the Farm B non-ventilated room. And then this is exactly the same data shown in the beginning. So they didn't get ventilated, therefore, steadily decline, the fresh mass declined over time. And then the upper one is the leaf lettuce, and the lower one is the frill lettuce. And then at the same time, Farm B continuously producing without obvious decline. And this is romaine data in Farm A. So the good one, good farm. So regarding thoughts, discussion, I'd like to summarize here. So the VOC experiment to test construction materials for lettuce showed that wood-based materials and silicon sealants, so those are exactly the materials used in Farm B, could cause phytotoxicity in lettuce seedlings. And then ventilation was shown as the most effective and simple solution to eliminate the problematic VOC that reduced lettuce crop productivity. However, ventilation is not the ultimate solution because ventilation largely affects the efficiency of CO2 enrichment. So you lose most of CO2 if you start ventilating. And you can't really increase the CO2 without putting probably, in some cases, 100 times of CO2 than necessity. So it's not usually recommended venting and CO2 enrichment together. And then also, of course, venting is additional HVAC cost, CO2 cost, so it increased the cost. In addition, ventilation changed the humidity level. Together, CO2 and humidity, of course, it can affect plant growth, and then also create another disturbance, and then to be consistent in terms of productivity. So it's not really an ideal solution either. So ideal approach, it's a long-term approach, but could have been, ideal approach could have been phytotoxicity testing at the time of selecting building materials. So in that sense, it is too late, right? So that you built already with the materials, didn't know it was safe or not. There's no information. But ideally, the approach should be testing materials, particularly if the materials are new, to be used in indoor farming. So conclusion, VOC phytotoxicity tests are highly recommended when an indoor vertical farm is designed and constructed. It's very important. So some of the take-home message, this is the last slide, so you can think about your questions. R&D need is obvious, VOC phytotoxicity test of various materials. So Shimamura-san is committed to continue examining phytotoxicities of different materials and sensitivities of different species cultivars to develop more robust knowledge-based database for considering in construction of indoor vertical farms. This is very important effort, and I myself support 100% that direction. This will help identifying mitigation procedures depending on the materials used and plant cultivars grown. So specific recommendations for this problematic Farm B, recommendation is repeated periodic ventilations to reduce the VOC levels. The data suggests that ventilation recovered the crop productivity, but the reduction could be, the crop yield reduction could be significant again when VOC accumulates, as ventilation doesn't eliminate the source of VOC. So the source is there, so as soon as you close, the problem comes back. And then according to Shimamura-san, the problem or the removal of VOC from the material which is generating or releasing VOC might take years, many, many years. So it may not be so simple. Another thing here, additional measures for Farm B. Fill the gap between seeding panels to maintain the containment so that if the source is outside of the production room, it doesn't come in. The VOC from the source doesn't come into the production room. Silicone sealants used for insulation siding must be covered or removed. Additional effective methods to remove VOC through adsorption or elimination, such as charcoal filter that does adsorption approach, must be examined. However, charcoal filter is a little tricky because if the compound size doesn't fit the pore size of charcoal filter, it doesn't work either. So try and errors probably needed in this approach. Exchanging problematic materials with safer materials must be considered as we accumulate more knowledge on VOC risks. Continuous efforts must be made for eliminating VOC. So that's the message, and then effort continues. And then Shimamura-san's was very much hopeful that Shimamura-san's team can develop more knowledge base so that contribute to industry sector worldwide who is operating and building indoor vertical farms. With that, I'd like to conclude. Thank you very much